It's about rice. It looks golden because it's got vitamin A added to it through a genetic enhancement. Tell me about golden rice and your campaign to allow it.
Golden rice was invented by two humanitarian scientists, professors in universities in Europe, one in Switzerland and one in Germany, Ingo Potricus and Peter Beyer. They were aware of the of the vitamin A tragedy in Asia and Africa.
So that's normal rice
and
there.
This is golden rice.
And it's obviously golden because it's got something added to it. It's vitamin A.
Well, the only difference between the two, conventional rice and golden rice, is that golden rice contains beta-carotene, which is what makes carrots orange and what makes corn yellow. But normal rice has no beta-carotene because the rice plant doesn't put it. Normal rice has lots of beta-carotene in its leaves, but we don't eat the leaves. It doesn't put any there. So therefore, 2 million people, mostly young children, die each year from vitamin A deficiency. More than malaria, more than HIV/AIDS, more than tuberculosis, which are the other main scourges. But those are diseases.
Yeah.
This is not a disease, it's a nutrient deficiency, and therefore you don't have to kill anything in order to fix it. You just have to put beta-carotene into these poor children's bodies, and they will be fine. And it's just ridiculous that
where are
people are opposing this.
In North America, we're so well fed. Most of us eat too much, not too little. Where are the places in the world where kids are dying or going blind because of vitamin A deficiency? Where does that happen?
India is a big problem, so is Bangladesh, so is Indonesia, so are many of the sub-Saharan African countries. It's basically 250 million preschool children are vitamin A deficient, and 2 million of them, including some, it's not all children that die from vitamin A deficiency, but mostly, 2 million die, and 500,000 children go blind each year, half of whom die within a year.
Now, I've talked about Ingo Potricus on the show before. He was one of the inventors of this. He said, this is for the world. I'm not looking to become a billionaire off this. I mean, he basically declared this is his gift to humanity, right? Tell me about the ownership of this technology.
Well, it wasn't just his gift. What he did was he figured out how to use the existing technologies of biotechnology,
right,
and what is today called genetic modification. But
right,
actually, genetic modification is a far broader term than just recombinant DNA biotechnology, which is what we're talking about here, where you take a gene from corn, in this case, and put it into a rice plant.
So this isn't like taking a mouse ear and putting it into this. Is
nobody does that.
So this thing
about putting fish genes into strawberries,
that's science fiction.
Is science fiction.
You know what? And it's funny you say that, because as folks who watch the show last, that's the kind of hocus pocus that David Suzuki was pushing. Taking a part of corn and putting it in the rice. Frankly, it sounds delicious.
It's the same gene that puts the beta-carotene in the kernel of corn.
Yeah.
They put that gene into rice, and it puts it into the seed, just like corn does. It's the same. There's nothing sinister about it whatsoever.
So back to the professor, Potricus. Yes. What did he and others do to get this idea used? I mean, it's one thing to develop. I mean, to save 2 million lives a year, that would be a greater salvation than almost any, probably up there with penicillin,
exactly,
in terms of saving lives. I mean, I can't think of another innovation that would so immediately, and innocent kids. I mean, this isn't, like you say, fixing a disease. This is stopping starving. Tell me how they went from idea to let's get this out there.
They created the invention in the lab by successfully transferring genes from corn to the rice, and grew a rice plant, and there you have the yellow corn, the yellow rice, which is golden rice. Then they went to the owners of the patents, primarily Monsanto and Syngenta. They created a humanitarian golden rice board of directors composed of people from around the world that are interested in this. Rockefeller Brothers is on there, Syngenta's foundation is on there, the International Rice Research Institute, and many others. And
I criticize Rockefeller Brothers Fund a lot, but it sounds like they're actually on the side of the angels this one here.
On this one they are, and on this one, the companies that own the patents gave them freely, to be given freely to any farmer in the developing world that sells less than $10,000 worth of rice a year. And the thing
that's got to be the majority of these are subsistence farmers.
But it's also the thing about golden rice is self-pollinating. Therefore, the seeds of the golden rice that is planted are true. Unlike plants that cross-hybrid, that pollinate cross, where the offspring are not identical to the original rice.
Right.
The golden rice seeds, the seeds that are from the golden rice, you can plant them again and you get more golden rice plants. So it'll multiply like wildfire.
So you're a poor farmer in India, you're earning less than 10 grand a year. Most people in India do.
Exactly.
You get this free GMO golden rice from Monsanto or this trust.
They still have to pay for their rice seed, but they don't pay for the trait of the golden part.
Right. So it's,
they're just paying the same amount as they would normally for rice seed. Whereas most genetically modified seeds cost more because they produce better.
So this is another very important development. Everything that's to do with the DNA, genes, technology will have a huge impact on what we eat, how we receive our food, the value, the nutrition that we can get out of food, the way that we make food, like crops resistant for drought, for other adverse weather circumstances that are about to occur more and more often because of global warming. At the other side of the spectrum, we are more and more capable of creating superfoods that will enable us to still feed ourselves, and maybe in a better way than we have done so far. Again, this is a legally speaking, a very difficult development, but it has a huge potential to feed ourselves much better, at least with more certainty, and to basically increase the way that we take food, and therefore also increase our life expectancy, even beyond what we are experiencing right now. So this is I think a very important development that will have huge impact. Now, who are going to lead this show? Of course, in the United States we have developments. It will be a little bit like what we see in the race that we see in pharmaceuticals, for example, where patents will play an important role. But also the open source movement, like basically what is described in this video, is that there are people who see so much benefit for the rest of the world that they are open sourcing it, more or less, not taking any money from the patents of this, but making it available to people in parts of the world where they're in need for this kind of enhanced food, and making it available freely over there.
Yeah, in the States, I think this kind of gene kind of manipulation or publication is very encouraged to do that. But European people is different opinion, right?
We are very careful. I think that we don't even have a very honest discussion about what it is. A lot of people basically outright refuse it without actually looking into the details and really knowing what we're talking about. So that will be a challenge to get the public acceptance for this. But I do see this to be a path that we cannot go back on this. We will not go back on this. Because the benefits are seemingly very big. You get much better crops, much better nutritious values. You can do a lot with this that is so beneficial that it will be difficult to eventually to stop it.
What kind of major change will going to be happening in next several years?
Well, it will, for example, mean a lot for farming, because if you have better crops, that will be easier to produce more food, better food, with fewer farmers. So for farming, again, it will mean a lot. I don't know how many of these projects will go open source. So that again means that it's an opportunity for farmers in Western countries where there's more technology, there's easier access to this kind of technology. So it might be an option that we will see farming in countries like the Netherlands, etc., take off, because like we have traditionally very close ties between the scientific world and the agricultural world. This I think probably the Netherlands is one of the most science intensive agricultural sectors in the world. Like we are the number 2 food exporter in the world, and we are like really the size of Kyushu. So that's very strange. It's just due to science and the way that agriculture has been organized. So for countries like the Netherlands, this is a huge opportunity to bring that export, to bring that technology and export it around the world. And the same could be true for Japan. Less reliance on outside of Japan for food. Local content might increase, and it's eventually will disperse throughout the world, and it will mean that we will have less food and grains and things go.